Okay, so we are moving into 3.5, which is, or no, sorry, 2.5, which is actually very similar to 2.3. So it might be better to call this 2.3 part 2. But this one's more focused on less sets in general and more surveys involving sets. And also it has to do with Venn diagrams with 3 circles. So a lot of this video is actually going to feel kind of like review, because I think I've covered, if not all of the concepts in my last video, which was pretty bulky. I think it was 30 plus minutes. If I haven't covered all of these concepts in that video, there's only going to be a couple of additional concepts. All that being said, this is worth kind of practicing and reviewing again. So let's get into it. So we're starting with what we in the worksheet last time. I think we had a question almost exactly like this of Venn diagram with 2 sets. And so this Venn diagram on the bottom right has, it was a survey given to students. The set A represents the students willing to donate blood. Set B is the set of students willing to serve breakfast to donors, presumably at a blood drive. And then 290 students didn't really want to do either of those things. That doesn't necessarily mean they didn't want to go to the blood drive. There is other possibilities. Potentially, we might have to have more information about the survey, but it certainly does not. Those are people who did take the survey and they are not willing to donate blood and they are not willing to serve breakfast to donors. Okay. So how many students are willing to donate blood? That is everyone in the A circle. So 370 plus 120 gets me 490. How many students are willing to serve a breakfast to blood donors? That would be my B circle entirely again. So the light blue region and the dark blue region, which would give me 340, not 330. The next question has me, how many students are willing to donate blood and serve breakfast? That's the and, that's kind of the upside down U as far as symbols goes. And it's represented in my Venn diagram as the middle part of my Venn diagram. So that's the dark blue, so that's 120. How many students, D is asking, how many students are willing to donate blood or serve breakfast? So I talked to a couple of students last class period about this idea of or. In the English language, we're pretty loose about that definition of or. Some people use or in the strict sense of you either do A or you do B, but you're not allowed to do both. Some people think you can do A or B or both. Those are all kind of true. And in mathematics, we kind of use that second definition, that it could be in set A, it could be in set B, or it could be in both sets. So to figure that answer, we just add all of the numbers in the circles. So 370 plus 120 plus 220 gets me 710. E is asking how many students are willing to donate blood but not serve breakfast. So that is also equivalent to the number of students who, sorry, I lost my line of thinking, are only willing to donate blood. And that would be the part of the circle A that is light blue, which is 370. F is asking very similarly, how many students are willing to serve breakfast but not donate blood? That's the people in the blue circle, or the circle of B, but light blue, only light blue. I don't want the overlap. So that is 220, that's F. G is how many students are neither willing to donate blood nor serve breakfast. And so that is going to be everyone outside of those circles. So again, maybe they are people that don't want anything to do with the blood drive and just are going home instead, or maybe they are hanging out at the blood drive, they just don't want to donate or serve breakfast. It's not really important. They are not in either of those sets, but they are in our universe. They did take the survey, and so that's the people outside of the circles and still in our universe. That's the 290. And then to figure out how many students were surveyed, well, we just add all of those things up. 370 plus 120 plus 220 plus 290 equals 1,000. So that's the answer to H. Now we're going to do the same exercise, except for now we have 3 circles going on. So our Venn diagrams are getting a little bit more complex. I think I've mentioned before, you could potentially have 4 circles or 5 circles, but then it becomes a little bit of a headache almost to the point that if like I was doing a high level mathematics question, I would maybe figure out a better way to represent things. But that's all that's to say, I do use Venn diagrams in higher level mathematics. This does have a lot, these do have a lot of applications in math and outside of math as well. Okay. So I have these three different sets. One is circle is men, B is African American, and A is agree. And so I imagine this is another survey where you had to kind of put check marks, and you could check all three things. Are you a man? Are you African American? Do you agree? Maybe you only check two of those boxes. Maybe you check one. Maybe you don't check any. And so that's kind of how this Venn diagram is built. And so the first question says, how many respondents agree with the statement? So I've put no conditions on the first question. I just want to know how many people agree. Don't really care if it's a man or a woman, if it's African American, if the person's not African American. And so that means I'm going to just add all of the things up in my A circle, which gets me, there we go, 18. 2 plus 4 plus 7 plus 5 gets me 18 people. Next question, how many people disagreed with the statement? And so now I go into my Venn diagram, and if it's disagreed, that's the same thing as not agreeing. That makes sense as far as English goes. And so as far as mathematics goes, that means everything that is outside of my circle. And yeah, 9 is not really part of the overlap of men and African American and agree, but that doesn't matter. Anytime you have a statement of not this thing, you do everything other than that thing. And so I add up everything outside the circle of A. So I add my 9, my 3, my 2, my 8, and I get a total of 22 people disagree with the statement. How many women agreed with the statement? So that is all of the people that A, aren't men, so aren't in the M circle, and B, agree with the statement. And so looking at that, that's my 35, it's definitely not 70. How many people, sorry for the disjointed feel, maybe that happened there, I paused the recording, but 35 is obviously not 70. I don't even know where 70 came from. Maybe I added everything up. But how many women agreed with the statement? So that means all of the people not in my men circle. So they could be African American, they could not be, but they definitely can't be in my men circle, and they definitely do have to be in my agreed circle. And so that is going to be 7 plus 2 is equal to 9. 36 is asking how many people who are not African Americans agreed with the statement. So it's a very similar process to the men question. I want to remove anything that is in circle B, the African American circle. And I also want to count the people that agreed with the statement. And so that gets me 2 plus 4 is 6. For 37, how many women who are not African American disagreed with the statement? So not African American, disagreed, are women. And now we kind of have to pause and think about that, let that digest a second. So I want to avoid everything in the M circle. I want to avoid everything in the B circle. I want to avoid everything in the A circle. So that just leaves me with 9. Those are the people that are in my universe, but don't fall into any of these categories. And something that I'm kind of not doing, but it is a good idea when you guys are working through these problems, is to kind of circle things. So I think I did do that in the last video, but circle these things or shade things or remove shading. Like if I was doing 37, I would kind of maybe shade each of the circles in red. So I could say, okay, not this, not this, not this. So that leaves me with 9. That's always a good strategy to when working through Venn diagrams. Now, finally, how many men who are not African American disagreed with the statement? So it has to be a man, so it goes in the M circle. Can't be African American, so not in B. Can't agree with the statement, so not in A. So that just leaves me with 8, the very top left number. That's for 38. And now we want to build a Venn diagram. And I don't know if there's a question like this on the worksheet, but if there isn't, I'll probably just pull something from the textbook. But usually when we do these, we want to build a Venn diagram. And then once we have the Venn diagram, answer questions like the last slide. But since I just did the last slide, I think I'm just going to focus on building this Venn diagram. So I think I talked about in the last lecture of when we were dealing with two circles, we kind of start from the very middle and then work our way out. That's kind of assuming that we know what the middle is, but if we don't, it's generally pretty hard to figure that out. So in most cases, we're going to have that big overlap of where the two circles intersect, or in this case, where the three circles intersect, and work our way backwards as best as we can. We might have to be a little bit careful how we are doing it. So with all of that in mind, I have my three circles I kind of built here. You don't have to use the same letters I'm going to use. I honestly just stole this picture from the textbook, so I don't really love the letters that I'm using. But that's fine. It doesn't really matter. What matters is that you label them and you tell me which is which. So C is the students in fraternities, D is students in tutorial programs, and S is the students in sports, which reminds me, I didn't use units on those last two slides, so I would not get full points on my exam. Make sure you're writing your units when you're answering these questions. So I read through my question, give you a second to read through it. Don't really want to repeat it because you'd see it in front of it. Okay. I guess I assume at this point you could pause the video if you haven't had a chance to read it. But I read through this whole thing and I notice at the end, I see the sentence 5 students participated in all 3 activities. Well, that kind of shouts to me that that's got to be the center of my Venn diagram. That is the overlapping, the people in frats, the people in tutorial programs, and the people in sports. So I throw a 5 right in the middle of my Venn diagram. And now I start to work backwards. So I don't want to focus on individual activities. Now I want to focus in on overlapping 2 activities. So let's see, working backwards, we see 13 students participated in fraternities and sports, 14 participated in sports and tutorials, and 12 participated in fraternities and tutorials. So let's see which one I do first. Okay, I do tutorials and frats. So I see there are 12 people that are in frats and tutorial programs, while I know also 5 students are doing all 3 of these things together. And so with that in mind, take that 12, I subtract 5, and that leaves me with 7 students that are doing just fraternities and tutorial programs. There are more students doing both of them, but as far as the people that are only doing that light blue region, I would take 12 and minus 5. And then I kind of repeat that process for the other blue circles. Let's see which one I do next. So I do D and S, tutorial programs and sports. So there are 14 people who do that, 5 people who do all 3. Well, 14 minus 5 is 9. You might guess how I do the next thing. I have 13 students that are in frats and sports. So that's C and S. 13 minus 5 gets me 8. Now is when I start to kind of move into the big circles, the people that are only doing sports, the people that are only doing tutorial programs, or I guess in tutorial programs, and the students that are only in frats. So let me see again where I start. I start with D, students in tutorial programs. So in the question, it tells me that 35 students are in tutorial programs. So that is going to be my D. So I take my 35, I subtract my 7, I subtract my 5, I subtract my 9. So that's, let's see, 12 plus 9 is 21. And so 35 minus 21 is 14. Now, what do I move on to? C is students in frats. So I see that 43 students participated in fraternities. And so I do 7 plus 5 plus 8, all of those kind of things in blue that are also in C. And that would get me 20. And then I take the 43 minus 20 gets me 23. And notice how order matters up to a point. It matters kind of where I'm overlapping. I need to make sure I do all 3 overlaps first, and then overlaps between 2 circles, and then the only circles, or the circles that don't do any other activities but that thing itself. But within those, like once I'm kind of in like the white part of my circles here, Well, I could have done the C part versus the D part first, and I could have done the S part first. That part doesn't really matter. So if you're working through a problem with someone in class or a worksheet with someone else and they say, oh, we have to do S first, that's not entirely true, at least once you get to this point. Again, when we're talking about the white part of the circles, they're like, no, we have to do the white part of S before we do the white part of D. That's not really important. Really, it's the big overlap, next overlap, single circles. Okay, and so I'm left with the students in sports. I add those things that are in my sports circles already. 8 plus 5 plus 9 gets me 1722. And then I have 52 participated in campus sports. So I do 52 minus 22 gets me 30. And now the last thing I have to fill out is the universe, the thing that things are that are not in C, not in D, not in S. And I look at the question and I'm told that 180 people were surveyed. So I add up all of these things, 23 plus 7 plus 5 plus 8 plus 9 plus 15 plus 30. And then I take that number and I subtract it from 180. So I assume that those numbers added up get me 96. And so 180 minus 96 would get me 84. And then there's my filled out diagram. So this is a pretty involved process. It's probably going to take a while when we are practicing it. But because what I would do typically when this question is asked is kind of follow up with how many students did both activities, or how many students were in campus sports and or did sports and were in frats but weren't in tutorial programs. And so now that we have this Venn diagram, we have a nice way to look at things and represent things and answer kind of those high level questions that seem like they are obvious up front, but they aren't necessarily that obvious when we like go through and build this. There's overlaps of these ors and the ands and everything that we have to be careful of.